All right, so let's try a really difficult looking thorny kind of limit. Right, we've got x times the cosine of x minus 1 as x approaches 0 over sine of x minus x. We certainly know this is going to be an indeterminate form by substitution. So what we're going to have to use is L'Hopital's rule, which told us take the derivative of the numerator denominator. Well, all right, let's do that. First of all, I'm going to rewrite this algebraically, make it a little bit easier on myself if I can. By the product rule in the numerator, what happens? Well, it is the first derivative of the first function times the second function. So the derivative of x will be is 1. So that will be 1 times the cosine of x minus 1. And that'll be minus, let's see, plus, right? We're using the product rule. Remember, this is no longer, we don't use a quotient rule. Be very careful right here, right? It's the derivative of the numerator itself. So right now in our numerator, we're putting the derivative of x times cosine of x minus 1. Okay, so keeping track. 1 times cosine of x plus 1 times x times derivative of cosine of x, so that's going to be minus sine of x. Okay, now in my denominator, I'm going to get the derivative of sine of x, which is cosine of x minus 1. That's sort of interesting. What could we do right here? Well, it might be fruitful to rewrite this fraction. In fact, we're going to have the limit as x approaches 0 of 1 times cosine of x minus 1 over cosine of x minus 1. Well, that's just 1. Plus, and then we're going to have negative x times sine of x over cosine of x minus 1. Now, does that help us? Well, we're going to get 1 plus, let's see, 0 divided by cosine of 0 minus 1. Ooh, that's 0, right? 1 plus 0 over 0 is still indeterminate, right? Because we don't know what's happening with that 0 over 0. So we're going to have to redo it again with this second fraction. So let's rewrite. We're going to take our limit as x approaches 0 of 1 plus, we don't have to touch that because we know what's going to happen with that limit, but this one, this expression right over here, we have to use our product rule. Okay? So dragging this negative out in front, what's going to happen? Well, we're going to have 1 times the sine of x plus x times the derivative of sine of x, that's cosine of x, divided by the derivative of cosine of x minus 1, which is going to be negative sine of x. Okay, so let's see if we can produce the same trick right here. Let's divide this second fraction into two pieces. So I'm going to be taking my limit as x approaches 0 of 1 minus, in parentheses right here, I'm taking that negative here, negative 1 minus x cosine of x over sine of x. Oh my, so we're still sort of in the same boat, aren't we? We're still getting that. Let's see, but we can reduce down a little bit again because we have this subtraction going on, right? 1 minus these two negatives, it'll be the same as the limit as x approaches 0 of 2 plus x times the cosine of x divided by sine of x. Interesting right here. What could we say about that? Well, in fact, cosine of x over sine of x right here, if we take the derivative of this second term, actually leads us to something kind of useful now. What could we say? Well, we're now going to get this quantity here. 2 will be added to the cosine of 0, which is 1, minus 0 times the sine of 0, so that's 0, divided by the negative of the cosine of 0, that's 1. So in fact, we're going to get 2 minus 1, and lo and behold, we've got the value of our limit. So sometimes we have to go through and rewrite so that we can get something useful, but we see that in our fraction right here. Multiple applications, this time again, 3 different applications of the L'Hopital's rule, eventually did produce a result.